Okay, so in this tutorial we're going to go over some basic assembly level debugging tools. So the first thing we're going to do is make sure that we have the source code fibc. We can extract it from the zip file that we got online, and we're going to make sure that it actually looks like what we think it does, so that we're not just arbitrarily executing code on our machine. And that looks like what we expect, so we can go ahead and compile it and even run it and see if it works like we expect it to. The -G flag puts the debugging symbols in there, which we need. Okay, well that seems to have worked, so we can move on to some tools that you might use in your binary, such as the strings tool, which dumps things out of the binary that might be strings. A lot of noise in there though. Maybe there's a more sophisticated tool we can use. The obj dump tool will give us a whole bunch of information about the symbols, but probably more than we really even want. So we can use something like the nm tool to get a little less, more useful information, and even some grep tricks to pull out specific types of lines, such as those that are names of user-defined functions. We might want to get at the assembly of our program, and we can use obj dump to do that with this disassemble flag. It'll give us a whole bunch of information though, so maybe what we really want to do is redirect that into a file that we look at with less. And we can just scroll through the whole assembly dump here and make sure things look like what we think, but really probably we want to get to the functions that we wrote and look at how those work. And so we can see the x86 assembly here for fib and main. So that all looks good. I'm going to delete the C file here so that when we move on to debugging, it doesn't get in the way and show us information that you won't have for your next lab. So GDB, to do our command line debugging as before, we call it. We can use commands like run, and it runs as we expect. We can set breakpoints at specific functions, and then tell it to run, and when we get to that function it will stop in its tracks and await commands from us. So maybe we want to tell GDB to display the program counter every time we look at a specific line of code. The /i there means show me the instruction in this case. We can use SI to single step through the instructions and then also step into any calls. As you see, it did there. If we forget where we're at in the program, the where command will remind us nicely, and we can even list our breakpointers with this info command, and maybe delete one that we've gotten bored of. If we want to see what the program looks like just before it terminates, we can set a breakpoint on the exit function and tell the program to continue running to that point, at which point it'll drop out, and then we can inspect the state of the machine with the info command, or maybe print a specific register. Whoops. Okay, there we go. We can print out chunks of memory, so in this case 5 instructions at the start of the fib routine. Or we could disassemble an entire function, if we can remember how to spell disassemble, which is a little tricky sometimes. Or print out a chunk of memory around the program counter. The X here meaning show me the hexadecimal memory dump. So satisfied with our very contrived demo, we'll continue, let our program exit, and then be done with GDB with the quit command.